Now let's look at the graph where we actually do have numbers. The first thing you ask yourself, what is this? This is x versus t, which means that this is velocity. It tells me how my position changes in time. So this will tell me about speed or velocity. Look at the numbers. So we have, this would be 35 meters away from whatever this is. So within 20 seconds, you moved from 0 to 35. This is a consistent slope, so it's a constant speed in the positive direction, and I can actually calculate it. I can do 35 minus 0 over 20 seconds, meters per second. Now what is happening here? My position does not change at all, so this would be rest. Now what happens between 40 and 50 seconds? Your slope is negative, so you're moving south. So you're moving south at a constant speed. And I can calculate that speed. Again, my change was 35. Change in x equals 35. Only in this case, it's a negative 35. Because I started at 35, I ended at 0. And then delta t was 10 seconds. So my speed is 3.5. My velocity is negative 3.5. meters per second because it's going south. Now what happens here, my object is at rest and then keeps going south, only not as fast. I can check that. This is 55 seconds, 65, 75, 80. So this is 80 seconds. And this position is going to be negative 20. So what happened here is my position went from 0 to negative 20, so negative 20 over 0 over, and the span of time was 25 seconds, negative 4/5 meters per second. Again, negative is because it's negative direction. Now what happens here is, again, we are at rest, and then we turn around and move back at a constant speed. So, constant speed, rest, constant speed going back, rest, constant speed going back, rest, constant speed going up. Now, identically looking graph, only this time it's v versus t. So this would be a graph for acceleration. It shows us how our velocity changes in time, if it does. So this one shows us the velocity grew from 0 to, you remember this is 35. So it went from 0 to 35 meters per second. So my acceleration would be, acceleration 1, I'm going to say, this is 1, would be 35 over 20 meters per second squared. Positive acceleration, I'm speeding up. So this is speeding up. Before, we said this was rest, but in our case, this is definitely not rest because my velocity is 35 meters per second. You cannot stay at rest and move at 35 meters per second. Well, you actually can, but that's outside of what we're doing right now. So 35 meters per second. This is constant speed in the positive direction because velocity is positive. Then I start slowing down because look what happens with my velocity. It was at 35 and it drops all the way to 0. So this would be slowing down, and acceleration is constant, and I could find it if I wanted. I would do 0 minus 35 over 10 seconds, and that would be negative 3.5 meters per second squared. Now what's happening here? I'm speeding up in the negative direction. My velocity changes from 0 to negative 20 meters per second. So I'm definitely, this is speeding up in the negative direction. Then here, again, this is not rest because this is v versus t. That is definitely not rest. What this is constant speed, only in the negative direction, because velocity is negative. And then our last leg here, velocity, even though it's looking up, it's a slope, so I know I'm accelerating, but how is my velocity changing? It was not 0, and then it became 0. So this is definitely slowing down in the negative direction. So one more time, since this is velocity versus time, that's acceleration, speeding up, constant speed, slowing down, doing a UE because you are going to change your direction, speeding up in the wrong direction, leveling out, moving at a constant speed, slowing down, and stopping.